Welcome, ladies and gentlemen, to sqadia.com. My name is Mohammad Osama, and we are talking about research designs in medical statistics and research. The topic that we're going to be talking about specifically in this lecture is interventional studies and different type of interventional studies, including randomized control trials and quasi-experimental trials as well. So interventional studies are very important because they are stacked as the highest form of evidence in terms of hierarchy of literature or evidence. They come only after the review articles such as systemic reviews and meta-analysis, but in terms of original articles, they are stacked in the highest most section of hierarchy in terms of evidence. So interventional studies test the effect of a treatment or a program of care. So in these studies, the researcher intervenes and gives any type of intervention, drug, treatment, or program of care. So the purpose is usually to test for the efficacy or the effectiveness of any treatment, any drug, any modality, or any plan of care. But in early drug trials, safety and dosage are established first, and then the purpose of efficacy comes into question. Now, when we are experimenting on individuals or when we are giving them interventions or drugs or treatment for experimental basis, then a lot of ethical concerns arise. The first thing is that it is not ethical to experiment on humans when the intervention is likely to cause harm. If you think that it can be harmful, then you should not conduct that type of experiment, ethically speaking. Secondly, it is not ethical to test whether environmental agents cause harm, and so you cannot intentionally give an environmental agent, or you can not intentionally expose a participant to an environmental agent which you suspect that can cause harm. So for that you can use observational studies to determine such effects, but not interventional studies, because that would be unethical. Now, interventional studies are of majorly two types: randomized and non-randomized. So randomized are known as actually randomized control trials, and they are stacked higher in terms of evidence as compared to non-randomized trials, which are, for example, quasi-experimental trials. And randomized control trials are further classified into parallel design randomized control trials and crossover trials randomized control trials. Now, usually when we talk about interventional studies, there are two groups or more than two groups, and we are usually comparing the intervention of question with any other intervention or placebo or something like that. So if there's a new treatment that I'm actually working on and I want to find the effectiveness of it, what should be the choice of control, which means what would be the control group. A control group is a group which is actually the group for reference that you compare the new intervention or the experimental group to. So the choice of the comparison group affects how we interpret evidence from a trial. So a comparison of an active agent with a placebo is likely to give a more favorable result than comparison with another active agent, because first thing is that it would actually give us the exact benefit of the active agent that we're actually trying to work on. And secondly, obviously, if the active agent has any contribution in improving the symptoms of a patient, then it would actually show a difference from the placebo, because placebo would just follow the natural progression of the disease. On the other hand, if we compare it with an active agent, so that other active agent would also have some effect on the disease, so the difference may not be that much big as compared to comparing it with a placebo. But the problem is that the comparison of an active agent against placebo when an existing active agent is available is generally regarded as unethical according to Declaration of Helsinki. And in that regard, we should always compare an active agent, which is the question of research, to an already existing active agent. But if there are different type of active agents, which one should we compare it to? we should always compare it to the best active agent available, which is known as the gold standard for that condition or treatment, and that has the minimum risk factors associated with it as well. So we should compare our active agent with the gold standard active agent, and then that is going to tell us if that treatment is effective. Because if it is not effective than an already existing treatment, then why use it? And if it is more effective than already existing gold standard treatment, then it is of importance and then it should be employed. Now, randomized control trial, the highest form of evidence in terms of original research. So a randomized control trial is an interventional study in which there are two or more than two groups, and the participants are actually randomly allocated to these treatment groups. That is actually a randomized control trial. And it is the gold standard of individual research studies, the highest form of original research in terms of evidence. So we said that there should be a random allocation, but the question is that how is this randomization carried out and what is randomization? So randomization makes blindness possible, because if I randomly allocate participants to two groups, I have no idea that which participant is going to go in which group, so I am blinded with that. So there is less risk of bias. Secondly, the allocation to treatment is unbiased, as I already told you, because if I want one treatment to be effective and I put all the participants in that group, which I think would have better prognosis, so that is actually biased. So if the allocation is random, then it is not in my control and it would be unbiased. Randomization also ensures that the subject's characteristics do not affect which treatment they receive. Because of randomization, there is an equal chance of any participant going into any group. So their characteristics do not affect which treatment they receive. The treatment groups are balanced by subject characteristics if we do a good sampling and randomization, and differences between the groups in a trial outcome can be attributed as being caused by treatments alone if the randomization is done instead of confounding variables. Now, how is this randomization done? For example, I took these 6 participants into my research study and the patient information is entered into a computer. Then the computer randomly assigns the patients to 2 or more groups to prevent bias and to make the researcher blind for it. And that is done through any software. So I get 3 participants in the control and 3 participants in the interventional group. And that was not on my behalf. That was random. And that means that it is not biased. Now, blinding, as I already told you, randomization leads to blinding. So blinding is when the treatment allocation is concealed from either the subject or assessor or both. Like, for example, I am the assessor and I don't know that what is the group of this participant or patient, like if he or she is in the control group or if he or she is in the interventional group. So that is blinding. Or if the patient does not know, the patient, for example, is receiving a pill, but the patient does not know that if this pill is the interventional pill or if this is the placebo pill. The patient also doesn't know that if what is his treatment or control group. So that means that the patient is blind towards the study. So if either one of them is blind, so this means that the trial is a single blind trial. If the assessor and the participant or the subject both are blind to the group, then it means it is a double blind trial. Now, it is done to avoid conscious or unconscious bias in reported outcomes. So if I have a preference towards one treatment, I cannot do the conscious bias towards it because I do not know that which participant is in which group. Similarly, a patient cannot consciously or unconsciously be biased towards one group. So the randomization makes blinding possible, and that is the most important role of the randomization. So randomized controlled trials lead to the blinding in clinical trials. Now, as I already mentioned, that there are 2 major types of RCTs. There are other types as well, but the most common are the parallel group design and the crossover trials. So let's start off with the parallel group design. So this is a trial with a head-to-head comparison of two or more treatments. So subjects are allotted at random by random allocation to a single treatment or a single control group for the duration of the trial, and that person or that individual stays in that group. So that is a parallel group design. So I put one patient in the control group and I put one patient in the interventional or experimental group, and that patient stays in that group and receives that same treatment for the complete length of the study. And at follow-up I take the outcome measurements of those participants. Now this is a parallel group design. Usually the aim is to allocate equal numbers to each trial, although unequal allocation is also possible, maybe perhaps because of dropouts. The groups are in this type of design parallel independent of each other because their participant stays in one and only one group. So we can understand it in a better way with this picture or graphical representation. So here are the patients. By random assignment, 5 patients went to the treatment group and 5 patients went to the control group. So they stayed in that group and they received the experimental treatment and they received the control or the basic treatment, and they stayed in this group. And at the follow-up, the outcome measurements were taken from both the groups and the results were compared. So this is parallel group design. Now, what are the advantages? The comparison of the treatments takes place concurrently, can be used for any condition, especially an acute condition which is cured or self-limiting, such as an infection, and there's no problem of carryover effects because you are not changing the group of the participants. The disadvantage is that the comparison is between patients and so usually needs a bigger sample size than the equivalent crossover trial for the generalizability of results and for significant findings. The crossover trials, on the other hand, is a single group study where each patient receives 2 or more treatments in turn. But initially, each patient is either put into the control or the experimental group, and each patient therefore acts their own control and comparison of treatments are made within patients. So one patient, as I already mentioned, the 2 or more treatments are given to each patient in random order. So the patients are divided, some goes into interventional, some go into control. They receive that treatment, and then after some time, to minimize the effects of carryover, they are then changed their groups and they receive the opposite intervention, and then once again the outcome is evaluated. So the population is randomized into intervention and control group, and then they are given that specific treatment, and then person or the researcher waits for some time between changing their groups so that the washout period is carried out so that the effects of the previous intervention do not carry on in the next intervention. So the group which was in the intervention group, it went to the control, and the group which was in the control, it went to the intervention after the washout period, and then their results are compared. So crossover trials are useful for chronic conditions such as pain relief in long-term illness such as osteoarthritis, and they are not feasible for treatments for short-term illnesses or acute conditions that once treated are acute, such as the use of antibiotics or infection. So if an infection is once treated, you cannot then change the group and once again see the effects of the other intervention. Avoid the carryover effect of one treatment into the period in which the next treatment is allocated, and that can be done by having a gap in between. So achieved by having a gap or washout period between treatments to prevent the effects being carried out into the next treatment. Now, what are the advantages and disadvantages of a crossover design? So advantages, treatments are compared within patients, and so difference between patients are accounted for explicitly because it is the same patient which goes into both groups. Usually, they need fewer subjects than the equivalent parallel group trials, and they can be used to test treatments for chronic conditions, and they're ideal for that. But they are not ideal for acute illnesses, so that is a disadvantage of those studies. Another disadvantage is that carryover effects need to be controlled, otherwise the results would not be valid. And they are likely to take longer than the equivalent parallel designs because the patients first go into one group, then they go into the other group. And the statistical analysis is more complicated if subjects do not complete all periods, so it is difficult to decide that how you're going to statistically tackle it in terms of analysis. Now, there are another type of trials which are known as superiority trials. Now, these trials depend on the aim of that study. So, if the aim is to seek to establish that one treatment is better than the other, then as the name suggests, it is known as a superiority trial. But when the trial is designed, the sample size is set so that there is a high statistical power to detect a clinically meaningful difference between the two treatments. Statistically significant result is interpreted as shown that one treatment is more effective than the other. For example, if the confidence interval is 95% and you compare the two treatment groups and the p-value is less than 0.05, so you can say that one treatment is significantly better at improving the result than the other treatment. On the other hand, in equivalence trials, the purpose is to seek to test if a new treatment is similar in effectiveness to an existing treatment. So even if it is similar, why are we conducting this study? Because it is appropriate for a new treatment which has certain benefits such as fewer side effects or being easier to use or being cheaper. So it is either having less side effects, either it is easier to use, or either it is cheaper. So that is a benefit, an added benefit, and it is also similar in effectiveness to an existing treatment. So if that is the case, then you can use equivalence trial. So it does not need to be more effective than the other treatment because it also has other benefits. So the trial is designed to be able to demonstrate that with given acceptable limits, the two treatments are equally effective. So even if a p-value is greater than 0.05 and there's no significant difference among the two treatments, then this is the finding of the equivalence trial. Non-inferiority trials, special case of the equivalence trial where the researchers only want to establish if a new treatment is no worse than an existing treatment. This does not mean that the new treatment has an added benefit or not. It just the reason for the study is to find out if it is any worse than the existing treatment or not, or is it similar. Now, quasi-experimental design. Quasi-experimental design are different to randomized control design in the terms that there is no random allocation or no randomization of the participants. Otherwise, it's pretty much the same. So that is why it is given a different name and known as quasi-experimental design. So what are the advantages of quasi-experimental design? That it can be used when randomization is impractical or not possible to do, or if the randomization is unethical. It is easier to set up than true experimental designs or randomized controlled designs. And as they are natural experiments, so they are not being actually controlled in a laboratory environment, so they are actually occurring in the natural environment. So findings in one may be applied to other subjects and settings, allowing for more generalizability for the population. So they may be less varied, but they are more generalizable. Efficient in longitudinal research that involves longer time periods, which can be followed up in different environments because the environment has no effect on the results of this study because these are natural experiments and they do not need to be specifically performed in a laboratory. Now, what are the disadvantages of quasi-experimental design? The disadvantages include that it is subject to contamination by confounding variables because these are natural experiments. So a lot of confounding variables come into play, and that may affect the validity of the study results, but it actually increases the generalizability of the results because it is a natural experiment. Lack of random assignment poses many challenges for the investigators in terms of internal validity, and it also increases the risk of bias. Study groups may provide weaker evidence because of the lack of randomness and biasness. So it means that they are stacked at a lower level in the terms of hierarchy of evidence as compared to randomized controlled trials. So that was all about the interventional study designs. I hope you learned something new out of it. And thank you very much for watching sqadia.com. Keep on watching for more lectures like this. Thank you.